Hello friends, good morning. Here I am Dr. Gadekar Sachin Pandit. Today discuss on CCTP course second and paper number 130. CHI 130 Inorganic Chemistry section second. Chapter second, Alkali and alkaline earth metal. Okay, last lecture we are discussed on different types of solvent. Okay, so in which we are discuss non-aqueous solvent. Okay, so in which we are discuss a ammonia and sulfuric acid. Okay, so in these two, in aqueous solution, water is act as a highly polar solvent and ammonia act as a low as compared to water. It's low polarizing ability as compared to aqueous water. And then discuss a sulfuric acid, non-aqueous solvent. They are protic. Okay, so ammonia is self-ionizing, sulfuric acid also self-ionizable, and its property similar like water. Okay, aqueous solution means similar physical property but different in its permittivity. Okay, so water has highly polar, that's why its solubility of salt is higher as compared to ammonia. Ammonia is lower permittivity or lower dipole moment as compared to water, and solubility is low. So second we are discuss a sulfuric acid. Its sulfuric acid is higher polarizability as compared to water, and it's a non-aqueous solvent, protic solvent. Okay, so in which next point today we are discuss on ammonia, solution of metal ion in ammonia, solution of metal ion in ammonia, NH3. Okay, you are familiar with this ammonia. In solution of ammonia we dissolve or drop a alkali metal, then alkali metal drop in ammonia solution becomes deep blue color, solution become deep blue in color. Why? Because metal ion in solution of ammonia forms a free electron. These free electron absorb UV light and they transmit color. Okay, so deep blue colors form. When if we add a excess amount of metal ion or drop a excess amount of metal ion, to forms a excess number of electron, and this electron combines with hydrogen and forms a bronze color, and then they disappear, means formation of H2 gas, hydrogen gas, and the electrons become utilized for formation of hydrogen gas. First alkali, these metal alkali metal ions drop in ammonium solution to form a blue color because formation of excess electron, and then they again add excess metal ion to form bronze color, and then evolve of water, evolve of hydrogen gas, and then the solution become colorless. Okay, so blue color because excess of electron formation. Metal plus ammonia to forms a metal ion plus electron NH3X. Or sometime like this. Okay, so solution conducts electron means in pass way electricity they conduct. Why? Because presence of excess electron. So these electron act as electron reducing agent. Okay, so this electron act as a reducing agent because they utilized for reduction purpose. And this, suppose alkali metals reacts at that time one electron reducing properties. Suppose alkaline metals we are dropped in this, then forms a 2 electron reducing agent. Okay, so example of reducing agent, first is they forms a superoxide and then peroxides formation takes place. First one electron utilized at that time forms a superoxide, and then again next electron utilized then forms a superoxide. Okay, first superoxide formation, metal plus electron plus O2, it gives superoxide O2 minus plus M plus. It is a superoxide. Then again this superoxide again use a 1 electron plus O2 minus to forms a okay, so this is the first formation of superoxide, and then they forms a peroxide. Okay, further reduction to forms a peroxide. Okay, so furthermore example, they reduce a platinum complex such as platinum second complex, also reduce PtNH3 4 times 2 plus metal ion plus 2 electron to forms a other byproduct. Okay, so this is act as a reducing agent. Okay, so here +2 oxidation state of platinum, and then they reduce. Second example of these alkali metal ion act as a reducing agent. Second example, molybdenum hexacarbonyl plus metal ion plus electron to forms oxalate ion. Okay, NaCO2 minus peroxide oxalate ion, and reduce Na4CO4 molybdenum. Sometimes we use Na4 molybdenum. These two oxygens utilize this 6 and other byproduct. Okay, so this metal ion solution act as a reducing agent. So next point is a BRF3. It is a Protic solvent. Okay, so this H2SO4 act as a Protic non-aqueous solvent. Here this is act as a Protic solvent. Okay, so a Protic solvent. Protic solvent again classify again three types. First is the polar. First non-polar Protic non-aqueous solvent. Okay, Protic non-aqueous solvent. Second is the polar non-polar and third is the highly polar non-aqueous solvent. These are the act as a Protic non-aqueous solvent, and this Protic non-aqueous solvent again classify into three classes: non-polar, polar and highly polar. Okay, non-polar, it is an example of CCl4, okay, chloroform. A Protic solvent CCl4. It is a Protic non-polar solvent. Okay, and they are not self-ionized. Okay, non-ionized compound. Another example, benzene. Okay, these are also a non-polar Protic solvent in non-aqueous solvent. So again cyclohexane, N-hexane, etc. This is the Protic non-polar solvent. Okay, so it is used when solvent play minimum role. Okay, this solvent useful when solvent play minimum role. Okay, so at that time these types of solvent we are use. And sometime in hexane, so many examples of non-polar. So second is the polar. Okay, polar but not ionizable. Such example is acrylonitrile, CH3CN. Second, DMSO, dimethyl sulfoxide, and third, dimethyl acetamide, CH3CO. Dimethyl acetamide. Okay, this is the example of polar Protic solvent. Okay, so these solvent coordinate slowly with cations and other acidic center. Okay, so example is this polar acrylonitrile DMSO or dimethyl formamide, it is a polar aprotic, and these act as a coordinate strongly with cations. Example: cobalt bromide plus suppose DMSO. Coordinate to forms a cobalt DMSO plus 2Br2. Okay, these types of reaction takes place in polar aprotic solvent. Okay, so this converts into this and forms coordinate with the, means these highly polar dissolve in this coordinate with DMSO. Okay, so second is DMSO or methyl nitrile. Its coordinate to forms a, its like this complex. Okay, so this is the example of polar aprotic solvent. Second, in this coordination is depends on the D and N. Okay, so DN and AN. This coordination depends on DN and second is AN. What is DN and AN? This coordination depends on the DN and AN, donor number and acceptor number. Okay, the donor number of the solvent and acceptor number of the solvent. Okay, so this is the example of donor number. It is measure of the basicity or donor ability. Donor number, it is measure the basicity or donor ability of this number. Similarly, AN means acceptance number. It is a measure that electrophilic behaving of solvent. Okay, so DN, donor number, it is measured by basicity or donor ability. Basicity or donor ability. And acceptance, it is an acceptance number, acceptor number that measure electrophilic behavior of solvent. Electrophilic behavior of solvent. So in this polar aprotic solvent, coordination is depends on the DN and AN, donor and acceptance number. Okay, so next is the highly polar aprotic solvent, that is BrF3, bromine trifluoride. It is a highly polar, highly ionized. Okay, polar as well as highly ionizable solvent, non-aqueous solvent, and they act as a acidic as well as basic solvent. Both properties are depends on its ionizable property. Okay, so in this first example of this high ionizing ability, so first example is the Sb2O5 plus BrF3, this to forms a bromine F2 plus ESB TF6 plus other byproduct. Okay, so other byproduct, and second example is ZO2 plus BrF3. It gives BrF2 plus cation form, and then second is ZF6, presence of d orbital and other byproduct. Okay, so in this reaction, BrF3, a protic non-aqueous solvent, these act as a acidic. Why? Because they donate fluorine atom to Sb. Okay, so and they forms a SbF6 types of complex. That's why in this aprotic solvent, BrF3 autoionize and they donate a fluorine atoms without its change, only transfer a fluorine atoms. Okay, so in it, fluoride salt dissolve unchangeably exchange fluoride ion transfer to form this solution, SbF6 minus. So next example, it's behave as a base like this. Okay, so in this reaction, just we are explain bromine trifluoride act as a acidic solution formation. So next example is the Kf plus BrEF3 in this two forms K plus BrEF4 minus. Similarly, AgEF reacts with BrEF3, it gives silver cation plus anion of bromine EF4 minus. Okay, in this reaction, this accept bromine and forms its bromine tetrafluoro ion. Okay, so accept, that's why this solution becomes basic solution formation. Okay, so this is the properties of a protic solvent, highly polar BF3 molecules. So comparatively we are discussed on this. So this is the highly autoionization power, and sulfuric acid also highly ionization. this is the high dipole moment as compared to ammonia. Ammonia is low dipole moment as compared to water. Okay, so in this, these are the proton donor, means proton, protic, and BF3 is the aprotic. There are three types. First is the non-polar aprotic. These are the non-polarized, and second is the polar aprotic, and these are also non-polarized, polar but not self-ionized. Okay, so this is the both properties. This is the highly polar as well as highly ionizable property, and it acts as some acidic solution. At that time they transfer only hydrogen to forms complex. And second example, AgF or potassium chloride, its donut chloride to forms its basic solution formation. Okay, so this is the properties of non-aqueous solvent media. Okay, thank you watching this video. Thank you all of you. Have a nice day.